Hello friends. These days we hear word digital quite often. We have seen world going from analog to digital. Students use word analog continuous, digital discrete interchangeably. Is there any difference between analog and continuous or digital and discrete? Because these words are used interchangeably quite often in engineering. So today I'll be covering up a small video in which I'll clarify, in which I'll explain what is the real difference between analog and continuous, digital and discrete. So first we'll start up with what is actually a signal. Anything in this world we are doing is with signal. For example, you have a traffic signal. If the light is red, we need to stop. It is conveying some information. So what is a signal? Anything which conveys some information is a signal, right? Now, mathematically in engineering, we represent signals as functions. We represent signals as functions. It means in the Cartesian domain, we represent a signal. Mathematically, we represent a signal as one axis is generally defined as an amplitude axis with respect to time. Now, what is the amplitude of the signal with respect to time? For example, at 1 second, let's say voltage of the signal was 2 volts. 2 seconds, the voltage of the signal was 3 volts and so on. Right? So signal mathematically in engineering is represented in Cartesian domain. One axis is reserved for amplitude and other axis is reserved for time. It might vary on x and y axis. It is not fixed for x and y axis. All right. Now moving ahead to the categorization of analog or continuous, we will check whether these are same or different. And digital and discrete. We will detail on these 4 types of signals. Okay, so mathematically, first we need to remember the signal definition of analog or continuous, digital and discrete is with respect to the amplitude or time. Okay, now signal is said to be continuous or discrete with respect to time axis. With respect to time axis. And the signal is said to be analog. Signal is said to be analog or digital with respect to amplitude axis. Now, amplitudes will tell you whether the signal is analog or continuous. Right, sorry. The axis will tell you whether the signal is your analog or digital. Time axis will tell you whether the signal is continuous or discrete. Now, the definition for analog or continuous is same. Means, for example, if I have a range of values from 0 to 1, how many numbers I can represent between 0 and 1? Infinite. I can represent 0. I can represent 0.111. I can represent 0.11112. Any number. On the real number line, I can represent infinite range of numbers between 0 and 1. Alright. Now, if I have the infinite set of numbers which can be represented on any axis, either amplitude or time, I will term the signal as analog or continuous. If I have infinite range of values for time, I'll say the term is continuous signal. If I have the infinite range of values for amplitude, I will say the signal is analog. Similarly, I say from 0 to 5, I have defined the set of values on which my signal will be defined. That is only on integer values, let's say 0, 1, 2, 3, 4, 5. Now I have a finite set of values on which my signal will be represented. Not the infinite as in the real number line from between 0 to 1. Now I have specified it to the set of values on which my signal will be defined. That is, now I have a predefined range. In that case, my signal will be either termed as digital or discrete. if I have a predefined set of range on time axis, I will term my signal as discrete. If I have a predefined set of range on amplitude axis, I will term my signal as digital. Okay, so we'll start up with the basic thing of bifurcating analog, continuous, digital and discrete. Okay, let's say this is the time axis and this is your amplitude axis. I'm saying, let's say I'm drawing a voltage signal Vt which is varying with respect to time. One thing I want to mention here is this is time t is equal to 0. So on the left hand side you will say it is a negative time, but negative time is never represented. Negative time is nothing, right? So if I'm standing here now, whatever happened yesterday is negative with respect to the time I'm considering now. Today, present, I'm saying from where I'm analyzing the signal is t is equal to 0. From where I have started analyzing the signal is t is equal to 0. Whatever happened behind that time, I'll say it is negative. So it is not negative time, it is now positive time, right? From where I have started observing the signal is t is equal to 0. Whatever happened before that was negative time. Whatever will happen in the future is a positive time. Mathematically, this is how we analyze the signals. Okay, so I'm taking one sample signal. Let's say I'm taking this signal. Let's say the range of the signal is, it is varying from 0 to 5. 0 to, let's say, we'll take 3 and minus 3. Now my signal is starting from minus 3 going till 3, right? And let's say the amplitude is from 2 to 2, this is 3, this is 4. Now, this is my signal. Now I want you to answer whether the signal is analog or digital or continuous or discrete. So let's bifurcate these 4 values. Okay, I told you the signal is continuous or discrete with respect to time axis, right? Now, if you see the range of time it is representing, the range of time is minus 3 to 3, right? Now the signal is taking infinite values from minus 3 to 3. It means your signal has some value at 0, which is this. Your signal has some different value at 0.111. It has some value, which is this. It has some value 0.1112 and so on. I will say 2.983. So how many time instants can be defined between minus 3 and 3? How many time instants? Infinite time instants. Your signal is defined at infinite time instants. All the time instants are taking some value for the amplitude. So you have your signal defined on infinite time instants which will come between minus 3 and 3. So your such a signal is continuous with respect to the time axis. All right. Now, going on to the amplitude axis, your signal is starting from the value 2 going till the maximum value is 4. All right. Now, between 2 to 4, I'm talking about the amplitude. Between 2 to 4, your signal can take any value. It could be 2. It could be 2.1113. It could be 2.456789, whatever. Right? So again, your amplitude can take any value between 2 to 4. Right? So such a signal will be termed as analog with respect to amplitude axis. So collectively, I'll say this signal is analog continuous. Okay. Now, what I'll do is I will sample this signal. Now, I hope you know what sampling is. Sampling is nothing. It means you are defining the preset range of the time instants. You will say that my signal will be defined only at these time instants. So let's say I'm saying my signal will be defined only at the integer time instants. Fine. So my signal will be defined only at integer time instants means 0, 1, 2 because there is no value existing above 3. So my signal will be defined at minus 1, minus 2 and minus 3. So what I will do is I'll say my signal is defined only at 1. So whatever the amplitude value is at 1, I will copy it here. Whatever the value of the signal is at 2, I will copy it here. So I'm taking some more range of values. We'll keep it as from -5 to 5 just to make it more explainable. 3, whatever the value is at 3, I'll copy that. Whatever the value is at 4 and 5, whatever the value of amplitude is, I'm not concerned what is the value, but whatever the value is, I will take it. I'll copy it here and let's say this is one. Okay. Now similarly, I'm just -1, -2, -3, similarly -4 and -5. I'm just copying the values. Similarly, if you will trace the values from the negative hand side, that is -1, -2, -3, -4, -5. Now, what has happened here? You have how many time instants? You have how many time instants? Tell me. You have 1, you have 2, you have 3, you have 4, you have 5. Okay, 0, whatever the 0 value was, we'll take it that also. 6, 7, 8, 9, 10 and 11. Now, the number of time instants here were infinite. If you have infinite time instants between -3 to 3, similarly you will have infinite time instants between -5 to 5 also. Alright, so you had infinite time instants here, but now the time instants are only 11. 5, 4, 3, 2, 1, 0, -1 till -5. What you have done is, you have specified a range on which your signal will be defined. Now, the signal with respect to time axis has become discrete, because time axis will tell you what? Time axis tells you whether the signal is continuous or discrete. But what has happened on the amplitude? On the amplitude level, whatever the value was here, I copied it here. Let's say the value was 2.3467. Here, whatever the value was, 3.99867. Whatever the value was between 2 to 4, I copied it here. Do I have a preset range of numbers on which your amplitude is defined? Yes, I know my amplitude will be defined between 0 and 4. The number of amplitude instants will be taken up by the time axis. But what is the actual value of the amplitude? The value of the amplitude, does it have any preset range? No. It will take whatever the value was, it will be copied here. So my signal, if it is 3.99867, it could take any value between the real number line 2 to 4, right? So my signal is still analog with respect to the amplitude axis. So such a signal is termed as analog discrete signal. So, okay. So what I will do is, I will quantize this signal. Now, what will happen if I quantize this signal? What will happen if I quantize this signal? Now, whatever happens with the sampling on the time axis, the same thing will happen on the amplitude axis. Quantization means I will define the level on which my signal will be defined. I'll say my signal will be defined only on 2, on 3, on 4. I will not have any other amplitude apart from 2, 3 and 4. So this is the time axis. On the original signal, I'm quantizing it. So my signal will be defined only from 2, 3 and 4. See, to understand what quantization means, we have to refer other lectures also, right? So for now, I'll be just specifying quantization at the basic level is, if you have, let's say your signal is between 0 to 0.5, I will assign it a value as a 0. If your signal is between 0 to 0.51 to 1, I will assign it as a value 1. Because my signal will only be defined from 2 to 3 and 4. So if it is, let's say, from 2 to 2.5, I will say the value will be assigned as 2. And if it is 2.51 to 3, I will define as at 3. Because my signal is supposed to take only value 2, 3 or 4. Alright. So whatever the values were, 2 to 2.5, I'll say my signal will take the value 2. Whatever the values were 2 to 3, I will say my signal will take a 3. And whatever the values from 3 to 4, I'll say my signal will take a value 4. All right. And we'll go something like this. I've just made a sample of it. Right? Now what has happened? Your signal is either taking a value 2 or 3 or 4. Right? Now these vertical lines, they don't represent any value in the signal. It just represents the connectivity. If you observe the same signal on the CRO, you will observe the signal as this way. The signal will be appeared as this, right? So in mathematically, in books, we represent the vertical lines to just represent the connectivity in the signal. It means it is a connected signal. All right. So, and the signal is still defined from -5 to 5. It is taking value 2, 3 and 4. Now, what has happened here? On the time axis, we can see your signal is still defined from -5 to 5. -5 to 5, it has a real number line. In between -5 to 5, it is taking all the values, right? So my signal is still a continuous signal. My signal is still a continuous signal with respect to time axis. All right. And what has happened with respect to amplitude axis? My signal is taking only the value. My signal is taking only the value 2, 3 and 4. So my signal has become digital with respect to amplitude axis. All right. Now the last step and such a signal is termed as digital continuous signal. Okay. The last step is if I sample this signal. If I sample this signal, now I have defined the sampling instance like here 0, 1, 2, 3, 4 and 5, -1, -2, -3, -4, -5. Now whatever the values were, it is 2, either 3. So whatever the values were, I will copy it here 2, 3 and let's say 4. Okay, so just a sample. Now the signal is taking either a value 2 or 3 or 4. This is 3, this is 4. Now on the time axis, your signal is taking how many instants? -5 to 5. You have a preset range of time instants on which your signal will be defined, which is from -5 to 5. Similarly, on the amplitude axis, your signal will take value only 2, 3 or 4. It means your signal has become discrete with respect to the time axis and digital with respect to the amplitude axis. Such a signal is termed as digital discrete signal. Now, a signal is termed as digital only if it is purely digital discrete. In books, we generally find words analog and digital. We hardly find this word continuous and discrete. Apart from signal and systems, we will not find these words continuous and discrete in other books. Generally, it is used analog and digital, right? So signal, it is termed as digital only if it is purely digital discrete. So on 4 types of signals, we will term only this signal as digital, right? Digital discrete signal is termed as digital, right? Apart from this signal, all the other signals are termed as analog. Until you convert the signal into purely a digital signal, the signal will always come under the category of analog signals. Be it analog continuous, be it analog discrete, be it digital continuous, because it is not converted into purely digital signal. Such a signals can be converted to binary forms, that is zeros and one for transmission. These signals cannot be converted to binary forms. Why? Because we have either amplitude or the time parameter has infinite range of values which we cannot convert for processing. We don't have such storage that we can keep infinite number of values. So all of these signals will come under the category of analog, be it this, be it this, be it this. All right, signal is said to be purely digital if it is purely digital discrete. So I hope you have understood what is the difference between analog and continuous, digital and discrete. This is the one basic thing in at least electronics and communication engineering which we need to understand before moving on to the basic subjects of communication and signal and systems. Thank you for today. And this video has been recorded with the collaboration with the Department of RISE, Research, Innovation, Startups and Entrepreneurship. Thank you.